Alright, so this is Foundations Pre-Calculus Math 10. I'm actually going to combine both section 7.2 and 7.6 together in our lesson today. Okay, we're going to solve systems of linear equations, and we're going to do this graphically. So a lot of the stuff we've done in chapter 6, especially with graphing lines, you'll need again. I'm going to introduce this chapter to you, or this section to you, by looking at this example. Okay, people can rent ski and snowboard equipment from 2 stores on Cypress Mountain. There's a place called the Ski Shack, and they charge a one-time fee of $30. And then after that, you pay an extra $5 per hour, depending on how many hours you rent their stuff. Now, the Boogie Board is the other company on this mountain, and they actually don't have a one-time fee, but they charge $10 per hour for equipment rentals. So like last day, what I'd like us to do is create a system of linear equations to model the rental charges. Okay. So looking at the Ski Shack, they've got a one-time fee and then this additional $5 per hour. So if you're thinking about creating a system, I think we're going to try to model charges. So maybe I'll call it cost. Okay. And the other variable, well, what other variable is there? Think about what's happening. You get to decide how many hours you get to rent this stuff for. So I think let's call C the cost. And maybe I'll call, I don't know, T the hours. And if that's the case, can someone help me by finding an equation that represents the ski shack's cost structure? Cost equals 2, and if you said it'd be 5 times t, very good, because for each hour it costs $5. But don't forget the ski shack also requires you to pay $30, no matter what. How about the Boogie Board? What are they charging? Well, their cost is really just $10 per hour, so 10t. Do they have a one-time fee? No, so you can put down +0 if you need to, but once again, not required. Okay, well, look what you have here. You have 2 equations with 2 variables. So the next thing I'd like you to do is graph out the 2 systems. So I'm going to graph this out, and because I know hours and costs are only going to be positive, I'm going to just use the positive region of the quadrants. So let's call this time. And maybe I'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and of course this is in hours. And then on my vertical axis, that's my cost, and because we're going up by $5 increments, maybe I'm thinking, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and then maybe 70. I hope that's enough. All right. So let's graph out the 2 systems. For the one in red, remember how we graph this out? Remember this is kind of like y equals mx plus b, so this is like the y-intercept, and that's the slope. So if the y-intercept is 30, that's great. And remember the slope means you're going up 5. So notice my scale here is 5 units, so I'm going to go up 5 and then 1 to the right. So that's this point right there. I'm going to draw my line now. Please draw it carefully, not like me. Okay. So there's my line for the ski shack. And I'm going to ask you to do the same thing for the boogie board now. Y-intercept of 0. Slope in this case is 10. So start at 0, 10, 20. Okay, here's my line for the not very good line. Boogie board. Okay. I think I should draw my ski shack one a little bit better. So hard. You know what? I should just go like this. There we go. I'm finding it so hard to draw lines. Okay. Alright. So the curious thing about what's happening here is that these 2 lines intersect. They intersect at a point of what they call intersection. And again, if you do this properly, you should see that the point of intersection is right here. And that, I believe, is 5 and 55. That's not right. Hold on. ladies and gentlemen, I'm drawing my lines again because they didn't do a very nice job last time. So once again, I'm drawing my lines. I'm actually gonna put a few more dots, and this looks like a better line. Yeah, there we go. So the point of intersection is where they intersect, and it looks like it's the point 6 comma 60. Okay, so where they intersect, that's the point 6 comma 60. Now what does this actually represent? Well, if you think about it, what it's saying here is that if you rent for 6 hours, right, the cost will be the same at both companies. And also graphically, you can tell that if you were to rent less than 6 hours, then boogie board would be the cheaper cost. But if you were renting more than 6 hours, then you should go with the ski shack. All right. Now, if two lines intersect, the coordinates, which we call x comma y, of the point of intersection are the solutions of the linear system. So today what we're trying to do is find the solutions of these linear systems. Last day we created the linear systems. Today we're going to actually solve for them. Okay? So let's use the ideas from chapter 6's slope y-intercept form section to help us out. Here, help me out with number 1. What's the slope? What's the y-intercept? If you said the slope is 2 and the y-intercept is 8, you're correct. Remember, a slope of 2 means you go down 2 units and you go right 1 unit. So here's 8, down 2, down 2, right 1, and so on. And we draw a line. Hopefully it's pretty good and accurate. It's kind of hard to draw on my computer with a ruler. See how hard it is? I'm not doing very well today. Oh well, you get the idea. You know what? I should do this better. I'm just going to do it by hand, maybe. Yeah. So much better by hand. Okay. How about the next one? You might want to change it into y equals mx plus b form by actually taking the positive x and moving to the other side. And if you do this, look what you have. The y-intercept equals to 6. The slope here equals to negative 1. So 6, negative 1, 4, done, done, done. And you get this line. Once again, if I'm asking you to solve the system, I'm looking for the intersection point, and it looks like it's right here, 2 comma 4. So that is your solution, and you can always double check, okay? You can always double check your solution by plugging it back in. So if I plug it back into the first one, I get 4 equals to negative 2 times 2 plus 8. Is that true? Negative 4 plus 8? You bet. If I plug it back into the second one, 2 plus 4, that gives you 6. You bet. So correct. Okay? And that's pretty much it. This is the main idea of this section. So if you can graph lines and you can find out where they cross, life is good. So you try example number 3 on your own. Okay? I will ask you to stop the video, and I want you to try it on your own first. And once you're done, come back to the video and actually take a look to see if your answer is correct. Okay? Go now. All right, so there's my answer, and those are my works. Take a look. I hope you have the same thing. You found the same intersection point. 4 comma negative 1. And notice I always put the x value first because x and y, well, x comes before y, so the x value comes before the y value. All right. So if you're good with this, let's take a look at our last example in this section, number 4, and then hopefully we can figure out what these equations are and graph out and solve. A parachutist descends from a height of 500 meters to 300 meters above the ground in 50 seconds. During that same 50-second period, a balloonist rises from 200 meters to 500 meters. So one's going up, one's going down, right? So write a system of linear equations to model the heights. Well, if you want to go back to the stuff in grade or chapter 6, if I'm looking at the parachutist, you're descending from a height of 500. So at time t equals 0, you're at 500 meters. And then 50 seconds later, you're at 300 meters. So if I want to do like slope and all that kind of stuff, well, I think you can. So let's call the parachutist P. The slope here would be what? y2 minus y1 over x2 minus x1, negative 200 over 50 or negative 4. Okay, so what's the equation of the parachutist? Well, I'll say then the equation of the line. How about the height, which I'll call h, equals to negative 4, and I'll say time, which is t, and my y-intercept I told you is 500, so there's my first equation. Then we got the balloonist. He rises from 200, so he's starting at 200, and after 50 he's at 500. So the slope for this gentleman or this lady, 300 over 50, which is 6. And then I think the equation of this line, that would be how about h equals to 6t plus 200. Okay. So here are your two equations, and guess what I want you to do next? Graph them out. Good luck. Do your grid. Do your time. Time. How about 10, 20, 30, 40, 50, 60. I guess that's seconds. Height could be a little bit harder. 500, hey? 500. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm at 500. Not that good. Let's do 50, 100, 200, 300, 400, 500. Oh, I guess I didn't pick many nice numbers, but nonetheless, what can we do? So there's 500. Now I know that if you want to do the slope stuff, it's kind of hard, but what we do know is we have two coordinates, 0, 500 and 50, 300. So I could just connect these two dots together to get my lovely line, which works for me. Okay. And then same thing with the balloonist. He's starting at 200, and after 50 seconds, he's at 500. That's what this is. And if you connect them, oops, I want my pen. Oh, that's not good. Undo. Okay, let's try again. There you go. And I guess you would try to find the intersection point, which is somewhere around there. Okay. Now, in this example, it's a little bit more complicated, I believe. You know what? Maybe I just didn't draw my line very well. should be going through right here. Well, I guess it's a little bit hard, but what I'll do here to try to help you out is that's why we have graphing technology. And in grade 11, you're going to use something like this. Okay? It's called a graphing calculator. And what I can do is I can actually graph out the two equations. So remember those two equations we had? Here's one. Okay, I'll go -4. I don't have the t, but I'll use x plus 500. And if I were just to quickly change my window, and I'll change this for you because you probably don't understand this stuff very well, but that's okay. Let's go 0 and 600. If I graph this out, look what you have. I just graphed out that line. Well, the calculator graphed out that line. Okay. Cool thing about this is now I can graph out the other line as well. So I'll go back to y equals 2, and the other one's 6x plus 200, and I'll graph that out as well. And there you got the line in blue. Now remember what we're trying to do? We're trying to find the intersection point. So we can actually use this button called trace, and it'll actually find it for us, or trace it. Looks like 300, 30, 380. Or I can actually use the calculator and use some of its features to actually calculate what the intersection point is. So once again, the answer here is going to be 330, 380. But, you know, sometimes doing it by hand, not so accurate, especially with big numbers. That's why we have this graphing technology. But in any case, what is the height at the moment in time? Well, at that moment in time, the height is 380 meters. Okay? All right. Let's move on to 7.6. Okay. Now, continue with this idea, we can take a look and determine how many solutions there are when you're trying to solve a system of linear equations with two variables. If you look at the possibility on the left, look at that beautiful graph. Well, how would we describe, well, first of all, how many solutions do you see? If you see one, you are correct. Now, when I talk about describing lines, I like to use the ideas of slopes and y-intercepts because we're familiar with that. So if I were to ask you to compare the slopes of these two lines, what would you say? Same, different? Different slope. Okay. So if the slopes are different, you see that you have one solution. What about the one next door? What are the slopes in this case? Yeah, they look the same. And in this case, how many solutions? Well, they're parallel lines, so there's no solutions. How about the last case? Well, they look like two lines on top of each other, so they also have the same slope. But in this case, because they're on top of each other, every single solution works. We call this infinite solutions. Now, if you look at the last two, we got a problem. We described the two lines exactly the same way. Well, they both have the same slope, yet one has no solution, one has infinitely many solutions. Problem. What can we do to fix it? What else can we use to describe lines? Yeah, how about the y-intercept? Good. So in each of these examples, what can you tell me about the y-intercepts? The one in the middle? Yes, they are different. Yet the one at the end here, where there's infinite number of solutions, yeah, it's the same. All right, let's summarize what you just told me. When there is one solution, notice that the lines have different slope. When there are no solutions, lines have same slope, but different y-intercepts. And when there are infinitely, let's say many solutions, they have the same slope and same y-intercept. Ladies and gentlemen, this is it for section 7.6. If you understand these 3 points, you're good to go. Because the questions are very, very simple. they just say, tell me how many solutions there are, but I don't want you to graph things out. So just by looking at the equations, can you tell me how many solutions are there going to be? 1, 0, or infinite? Well, what I'd like us to do then really is we need to find the slopes and y-intercepts. And the best way to do that is always to change every equation into the slope-intercept form. Y equals mx plus b. All right, so the first one, I'll change. The next one's a little more tricky. 3y equals to x plus 6. Divide both sides by 3. And I want you now to compare the slopes and the y-intercepts. We'll always compare slopes first. Are the slopes the same? Not in this case. So automatically, because they're different, you know there's one solution. And I'll say because the slopes are different. How about part B? Well, once again, you're going to have to rewrite this in slope-intercept form. I know I'm going a little bit fast, so if you're listening at home, just pause the video and rewind if you need to. So in this case, look at the slopes. Oh, they're the same. Look at the y-intercepts. Oh, they're different. Same slope, different y-intercept. No solution. Last but not least, I will do this really quickly. You can probably predict which one it's going to be. Same slope, same y-intercept, infinitely many solutions. All right. Now there's only one other time. Well, there's only one more thing we can do. Switch it around. So now I'm going to ask you to consider one equation, and you have to give me a second equation to figure out what that would look like. So it says write a second equation such that the linear system will have no solution, then one solution, then infinitely. Now think, before we do this, I always said find an equation in slope-intercept form. So let's go ahead and try to redo this and write it in slope-intercept form. Move the 3x from the left side to the right side. And now I'd like you to divide everything by negative 4. So that becomes 3 over 4x. Negative 8 divided by negative 4 is just positive 2. So if I want something that has no solution, what do we need? No solution, lines must be parallel, yeah, which means same slope, different y-intercept. So really I need slope to be the same, and this y-intercept number should be anything except what number? That's right. So there are many different answers. You get to choose whatever one you want. Okay. If I only want one solution, what must we be? Well, they have to have different slope. So really anything where the slope number, anything but 3/4. And this number over here, well, that can be anything because I don't care if there's a y-intercept or not. So as an example, pick your favorite number. Mine's negative 5, sure. So there you go. That's an example. I guess back up here, I'll give you example 2, maybe 3/4 x plus 1. Okay. And then for the last one, infinitely, of course, we need the same slope, same y-intercept. So you could just write the same equation again. Okay, plus 2. Sometimes that's kind of tacky, so people will just rewrite this as, hey, let's write 3/4 as 6/8. Yeah, that sounds kind of fun. And I write the 2 as 8s as well. I don't know, like this. Okay. Once again, as long as they're the same thing, they're okay. So same slope or equivalent form, right? Because 3/4 equals to 6/8. And the same y-intercept or equivalent form because 2 is equal to 16 over 8. That's it. Time for you to do some homework to try this on your own.